Hello everyone, I'm here with new topic. Our topic is diazonium coupling. Uh, there is different reactions and preparation of different type of dyes. First one is phenol orange dye, second one is aniline yellow dye, and third one is naphthol red dye. Phenol orange dye is also called methyl orange. First we see phenol orange dye. Phenol orange dye is also called carbon nitrogen coupling or diazo coupling. In this benzene diazonium chloride react with phenol in the presence of base NaOH uh, in pH between 9 to 10. We get diazonium coupling or phenol orange dye. There is whole mechanism how phenol react with benzene diazonium chloride and how it reacted with base. So first we see how phenol react with base. Here base is NaOH. When ionic substitution is there, it substitute into Na positive or OH negative. OH negative, this is an base, and this abstract an hydrogen or an proton from this side. So there is one negative charge generated, and that negative charge attack on that bond, and this is shifted there, and this is shifted on there. So negative charge is generated that position. Next it react with benzene diazonium chloride. This negative charge attack on nitrogen, and this bond shifted on that side, and that time chloride is removed, because we know that nitrogen not form 4 bond, it only form 3 bond. When 4 bond is formed, it is unstable. Next step, chloride is removed from there in with negative charge. This is attack on that hydrogen, and that bond attack that bond shifted there. Again, when this bond shifted there, and this is shifted there, and again a negative charge is generated on in oxygen. When after that it react with HCl, and this negative charge take hydrogen from that position and form OH group, and this is called phenol. This is called phenol orange dye or methyl orange. Next we see about aniline yellow dye. In aniline yellow dye, aniline is reacted with benzene diazonium chloride, uh, and we get benzene yellow dye. Next we see mechanism of preparation of benzene yellow dye. In this, the lone pair of nitrogen attack on that bond or that side, and this bond shifted there, and again this shifted there, and the negative charge is generated. Next, same as it is phenol orange dye, and this negative charge attack on nitrogen, and this is shifted there, and chloride is removed. Next, hydrogen when next we see chloride attack on that hydrogen, and bond is shifted, and stability is gained, and again this bond break as a lone pair, and we get yellow dye. Next we see naphthol red preparation. In this, dibenzene phenol reacted with benzene diazonium chloride, and we get naphthol red. And there is mechanism, and in this the pi bond of benzene is attack on nitrogen, and this bond is shifted there, and next position this is come back, and chloride is removed, and next again chloride is attack on abstract this hydrogen and bond is shifted there and aromaticity is gained and we get naphthol, right? Next we see another reaction. This is very important reaction called Vilsmair reaction. In this reaction we use reagent POCl3 plus DMF. DMF is dimethyl formamide and this is the structure of DMF. In this formation of aldehyde is done in the presence of POCl3 and DMF. On first step, POCl3 and DMF reacted together and form when POCl3 and DMF reacted together it formed iminium ion as an intermediate of Vilsmair. It reacted with benzene ring and formed and this is the mechanism, this is whole mechanism of Vilsmair reaction. At last product we get aldehyde group. uh, the question, what is the Vilsmair intermediate? The So our answer is iminium ion. Intermediate of Vilsmair reaction is iminium ion. Here I draw the whole mechanism of Vilsmair reaction. So let us start. So this is the structure of POCl3 and this is DMF. First we see how negative charge is generated in DMF. This lone pair of electron attack on that position and this is shifted there. We get N double bond C O negative H Me Me is methyl. Okay, next it react with POCl3. This negative charge attack on phosphorus and this bond is shifted in oxygen. We get O P O negative Cl and Cl and there is double bond nitrogen Me and this is hydrogen. And next way this bond is again shifted there and one chloride is removed. We get oxygen phosphorus double bond oxygen chloride and this is carbon hydrogen double bond nitrogen Me. Here we see four bonds of nitrogen and we know that nitrogen not stable in four bonds, so there is plus charges in nitrogen. Next the hydrogen uh, chloride which is removed from there as an minus uh, negative with negative charge. This is attack on that carbon and this bond is break. We get CHCl and Me and this is positive and next PO2Cl2. On next step this is reacted with benzene ring. Pi electron of benzene ring attack on that carbon and again chloride is removed from there. We get this and there is carbon attached and nitrogen Ne. So next way, uh, minus Cl is take minus Cl take this hydrogen, and again this bond is shifted there, and aromaticity is gained by benzene ring. On other hand, it reacted with water or hydrolysis is taken place. Uh, their lone pair is attack on carbon, and this bond is shifted there. We get on next way. We know that oxygen only form two bond, so for stability of oxygen this bond is shifted there, and stability is gained by oxygen. We get benzene, carbon, hydrogen, nitrogen, NeNeOH, and this is next step. This lone pair of electron attack on that bond or that position, and this is removed from there. We get benzene, CHO, and this is an aldehyde group or called aldehyde benzene or benzaldehyde. So this is whole mechanism of Vilsmair reaction. Next we see Gattermann-Koch reaction. This is also important reaction. In this reagent is CO plus HCl. In this also formation of aldehyde is taking place. Firstly, CO, carbon monoxide, is reacted with HCl, and it forms an intermediate or an ionic form. It again then it react with benzene and form aldehyde. Mechanism of formation of aldehyde with the help of Gattermann-Koch reaction is we know that carbon monoxide is reacted with HCl, and then after it react with benzene and form benzaldehyde. And next, formation of N-isoldehyde from anisole. So anisole react with this group and form uh, N-isoldehyde. This is anisole oxymethylbenzene is reacted in the presence of CO plus HCl, carbon monoxide plus HCl. These both reagents react together, form this one, and this is reacted with this and form anisoldehyde. Here our topic is completed. For more updates, please like, subscribe and share.